Start.
Okay, thank you. Good afternoon, dear colleagues. I want to present my work, Guaranteed Defibrillation on Cardiomyocyte Model. Despite the considerable period of experimental and clinical use of pulse defibrillators, there are still no complete clarity this mechanism of heart defibrillation. The aim of this work is more detailed study of defibrillation mechanism and comparison with available experimental data to confirm the representation that guaranteed defibrillation mechanism is external defibrillation mechanism. Next slide, please. The study was carried out in beatbox simulation in environment on 10 tissues panfield model of human heart ventricular myocyte for two pulse forms, half sine and radical. In this study, pulse energy was calculated during the simulation. The response of cardiomyocyte in state of simulation fibrillation to effect of depolarization current pulse was evaluated. Simulation of fibrillation was caused by excitation impulse of 0.5 millisecond duration with frequency of 240 Hz. In determining the threshold of guaranteed defibrillation, the defibrillation pulse acted on cardiomyocyte model immediately after exposure to excitation impulse. The threshold amplitude of defibrillation pulse was fixed when excitation of cardiomyocyte model was suppressed at action in the next excitation impulse. Next slide. The result we checked for compliance with low Hoover-Weiss-La peak present on this slide. Next slide. For half sine and reticular excitation impulse depends the threshold excitation energy of cardiomyocyte model on excitation impulse duration we constructed. This depends in shown in figure. The values of pulse duration relative to duration, the energy optimal, the duration optimal pulse depending the threshold value of excitation energy of 1.2 emin and 1.5 emin present in table. Curve that depends of threshold excitation energy on the duration the excitation impulse correspond to Hoover-Weiss-La peak law only in first approximation. Deviation of curve that depends the threshold excitation energy on Hoover-Weiss-La peak law depends on wave of impulse. Next slide. Dependence of threshold energy of guaranteed defibrillation on duration at acting half sine and in rectangular pulse present figure 1 and figure 2 respectively. For rectangular pulse, minimum energy coefficient of guaranteed defibrillation is 23% higher than for half sine pulse. The ratio of duration of energy optimal pulse of guaranteed defibrillation to duration of energy optimal excitation impulse for half sine waveform was 2.37 and for rectangular waveform 2.42. Next slide. The values of pulse duration relative to duration of energy optimal pulse depending on the threshold energy values of guaranteed defibrillation of 1.2 emin and 1.5 emin present in this table. From previous two slides, it's follow what for cardiomyocyte model. In first approximation, curve of depends of the threshold energy of guaranteed defibrillation on the duration. The defibrillation pulse correspond to Hoover-Weiss-La peak law on limited range relative values on the pulse duration. For rectangle pulse, this range is much higher than for half sine pulse. Next slide. The result obtained of half sine pulse seems paradoxical. However, we can compare this result of animal experiments. The result of experiments on defibrillation with monophasic half sine and biphasic quasi-sinusoidal pulse are present in table. Unfortunately, model of cardiomyocyte are imperfect. For half sine pulse in cardiomyocyte model, the energy optimal duration was 53 milliseconds as indicated above, and according to the result of experiments, it was 5 milliseconds. Therefore, to compare the data, diminishless values of the duration relative to duration of the energy optimal pulse were used. Figure represents the comparison result, where dots represent average values of result. As can be seen from figure, the result obtained of cardiomyocyte model are close to the result obtained in animal experiments. Next slide. Next slide is main result and conclusion. Thank you for your attention.
Okay, so thank you very much. We are waiting question from our participants, and I ask first questions because some people have no time for react and write questions.
Okay.
I want to ask you about time of about performance of your solution, because when we calculate Cardiomyocyte model, we should introduce some changes in differential equation or in algebraic equation, which we solve during the simulation process. And does it's how this solution affected on performance of the solver?
Oh, please repeat, please, your questions. I understand you.
When we calculate some cardiomyocyte models and make some simulations, we need to introduce a method of activation into the algebraic equation in your model. And usually it happened with usual impulse wave in some time. But when you introduce your approach, how it affected to performance of the computational cost of your simulation?
Okay. I think I don't answer these questions.
Okay, thank you. I'm writing question from chat or other participants. Maybe we have problem with some configuration. Okay. We have no other question.